And welcome to the Daily Space Weather, folks. Looking at the sun here at 171 angstroms. We see a plasma filament up there in the northwest. That's why we're zoomed in. And that plage there, north of the equator there, underneath my arrow, has degraded. So it has not turned into a sunspot. We see some filaments down south also. And here's the southern region and your date stamps. Coming at you a little later today, folks. And there you see that plasma filament down there in the southeast as well. Very low levels of solar activity. Let's look at some more views. Here's 94 angstroms. And I think we've improved the quality of the video a little bit again today, folks. Taking another step in reducing the amount of lag, basically. And I'd like to introduce another section, a new section that we're going to start covering occasionally. It's the GOES proton flux. And I would just remind you that 90% of cosmic rays, folks, are protons. The solar wind is essentially cosmic rays. The other roughly 10% are made up of mostly, respectively, alpha particles, then electrons, and then everything else on the periodic table. And if you want to monitor cosmic rays, we always leave links below the video to the Network of Cosmic Rays Station's site. Let's look at some more data here. We did see a B-class X-ray flare there on January 19th. It was quite weak, barely even into the B-class range, and was associated with the release of a coronal mass ejection facing the opposite way from the Earth, heading out to space, out toward, I don't know, perhaps Mars. I don't really know for sure. Anyway, here's the GOES X-ray imager, and you can see the degradation of that plage region located under my pointer there. And thanks to new viewers who haven't watched the video yesterday. By the way, we've made hundreds and hundreds and hundreds of space weather videos, as well as some other varied content, so perhaps check out our video list if you haven't done so. And you can see the degradation of that X-ray zone there, producing less X-ray flare there. So basically a reduction in solar activity over the past 24 hours. Let's talk about neutrons on a plane real quick at spaceweather.com. They do list hot flights there. And there's a nice article here about bubble chambers. That's right, bubble chambers, when neutrons show up and they vaporize tiny water droplets and they create bubbles inside of planes. Those of you not aware, your cosmic ray exposure goes up massively, especially on polar flights. So in any case, these are secondary particles from those protons crashing into the Earth's atmosphere. And let's get back to the data here. Again, that is at spaceweather.com. 10.7 centimeter radial flux still at 72, and KP index still at 1, having been at 0 for a good portion of the last 24 hours. There's the data from the ACE solar wind. And we saw a recent shift in the past 8 hours of the BT-BZ to a highly positive BZ and a very high level of BT. And the magnetometer data corroborates that. Here's the real-time solar wind from the Discover, which is a little bit more detailed for you there, folks. And you see the phi angle's currently at 57 degrees, having recently shifted all around. We have a small coronal mass ejection-like impact there, very weak. It did bring the density up to a little higher, off the floor at least. And the solar wind speed has come up, having been all the way down to 277, which is about as low as we ever see it. Now the current solar wind speed up to 306, which is incredibly low solar minimum solar wind speeds. Next, we're going to look at the geospace magnetic perturbations here. I'm sorry, the geospace magnetosphere movies. And we see a very low density solar wind. And you're going to see it fluctuating here, similar to what you see on the solar wind graphs. And here is the predicted model from that data. Keep in mind this includes all kinds of other stuff like electron flux and magnetometers. So very, very diffuse solar wind there and very low speed. And here's the pressure, looking super weak. And if you want to read about how this data is derived, it's from the Space Weather Modeling Framework. Just click the links below the video. You'll find this Geospace Magnetosphere movie link. The Van Allen belts look very large and very far away from the Earth right now. And those would be the areas around the empty space. See the empty space, that's the plasmasphere. And lining each end of that plasmasphere is a belt of electrons. Anyway, again, if you want to read about the Space Weather Modeling Framework, just scroll down here, click on Details, click on Space Weather Modeling Framework, and you can read all about it. Next, we'll look at geospace ground magnetic perturbations. And we don't see very many. We'll let it play through anyway, just to show that there's not a lot to show. Welcome to the magnetic excursion, folks. We monitor it every day. This is 4 hours of data, both from the space view and from the ground view. Relativistic electrons are still quite low, actually. And GOES electron flux still low, a little bit higher. Small little uptick there coming right after midnight. So perhaps we're going to get that electron flux uptick that we were expecting. I still would expect to see a small uptick in the electron flux and have it not be quite as cratered as it currently is. And let's look at the ionosphere, which is extremely turbulent. It's gone from extremely discharged to significantly charged in a very short period. As you can see, that area right there is some of the most discharge we ever see. The ionosphere, especially on the sun-facing side, only making it up to 6 and 7 megahertz there. I'll let that play through a second time, especially since we're coming at you so late, folks. And there's the older data, and you can see a very, very discharged ionosphere there. Very low amounts of pressure, you could say, however you want to say it. And then having that turn back into a more normal ionosphere. So it was very weak there. And now it's looking more normal, having made it all the way up to 12 megahertz for a moment. There's the current data at noon universal time. And there you see that magnetometer data. We see pretty high readings and a significant disparity between the GOES 14 and the GOES 16, shown in blue and red respectively. Here's the Gong 2 data. Nothing too exciting to report on there. A little bit of plasma activity there in between stereo A and the Earth. So there could be some activity rising there. I wouldn't be surprised to see some activity north of the solar equator based on what I see there. And there's the last image. That data 1 hour 42 minutes old, coming in at 10:04 UT. Next we'll look at earthquakes. And I'm just going to scroll up the list. We saw another earthquake in the eastern US there. It's not big enough to report on, so we're not going to report on it. It was a 3.8 in Tennessee. It's as if they're getting closer. And just scrolling up the list, we see a very deep quake there near Fiji. There's a 4.5 magnitude quake at 539 kilometers depth. I believe the largest of the past 24 would be this 5.3 at Costa Rica. Here's a deep Mexican quake. That one at 125 kilometers and a 4.8 magnitude. Deep quake in Indonesia, 156 kilometers and a 4.6 magnitude. And a Costa Rican 5.0 magnitude coming in as we did the show prep. Coming at you a little bit late today, folks. If you're wondering what time it is, it's 7:04 a.m. And we're looking at the pressure maps here on windy.com. We'll just let that advance. Anticyclone over northeastern Greenland, as well as over the eastern U.S. And we'll let that get to about 24 hours from now. There's where things will be at 13 Zulu according to the GFS model. Next, we'll look at volcanoes for today, January 21st, 2020. A date where I get to go to court, just like President Trump. I'll tell you about it later. Mount Aso is erupting, producing a 6,000-foot ash plume. Sakurajima, same deal there as it explodes. Semaru, 13,000-foot plume there. Mount Takono exploding. Flight level 6,000. Residual ash dispersing at Shishaldin. It looks like it stopped erupting. Popocatépetl. Some volcanic ash observed in satellite. Fuego, 15,000-foot plume there as it explodes. Sangay exploding, 23,000-foot plume. Revenador exploding, 15,000-foot plume. Sabancaya, intermittent emissions, and Nevados de Chilean erupting enough for me to suggest that you don't pole vault the caldera. And there's the current state of affairs with lightning. A little bit of lightning in around the Mediterranean. And here's the jet streams on nullschool.net. Extreme meridional jet stream flow, jet stream splitting, doubling up, tripling up, and quadrupling up all along the northern hemisphere. A totally jacked up jet stream. Here's the eastern world. And it looks like some very cold air coming from Antarctica to southwestern Australia. And extreme meridional jet stream flow. Check out this area right here, folks. The jet stream making a more than 180-degree turn, traveling from east to west over Central Europe. So that is some absolutely insane jet stream flow right there, folks. Here's the U.S. Doppler radar map as we bring you some value-added services, showing you where it's snowing and where it's blowing. And let's take a look at the Great Salt Lake. I don't know why the heck it zoomed me in there. I must have gone too far north. There we go. Looks like a little bit of snow and ice falling in the mountains down there. Anyway, let's move on to talk about climate change. How about an article that refutes itself? What a surprise, huh? Now, you're going to see this one all over the internet today. Ozone-depleting substances cause half of the late 20th century Arctic warming, says study incorrectly. And it didn't take too long to find a mistake. In the study, the ozone-depleting substances allegedly acted as a strong supplement to carbon dioxide, the most pervasive greenhouse gas. So obviously this study written by somebody that does not understand atmospheric physics, since everybody with their head out of their you-know-what understands that water vapor is by far the most pervasive greenhouse gas. It's the only gas that measurably acts like one, at least on this planet. So that didn't take too long to find a mistake, did it? I feel like Tony Heller at this point. Anyway, I'll just scroll down here and allow everybody to read the rest of this nonsense. And of course, while pollution is a real thing, climate models do not understand the role of gases in the climate. So it's going to be all over the internet today. You're going to hear all about how polar bears are dying because the ice is melting. Oh my gosh, not the poor polar bears, not the poor man-eating, stalking, insane predators known as polar bears, which, by the way, have problems when it's too cold in the Arctic because there's too much ice and they're unable to get to seals, their primary source of food, their favorite source of food, which drives them southward into towns and then causes people to think that their habitat is being destroyed because the Arctic is melting, when it isn't. Anyway, here's another article from Cosmos magazine getting into the same nonsense about the climate. And yeah, whoops, oops. Anyway, we'll leave links to this as well. The total snow mass for the northern hemisphere, and as you can see, it's at least a full standard deviation outside of the 30-year average. So it's actually more like 2 standard deviations. As you can see, the dotted line is the average, and the blue bar above the dotted line is 1 standard deviation. It's at least 2 standard deviations. Enough said. And here's the planet's real greenhouse gas, known as water vapor, which is showing up here in the blue colors. It looks like there's another atmospheric river forming, and it's being held in place by a lot of dry, massive air. For those of us who understand atmospheric physics, here's where there's more massive air. And if you notice, this moist air is colliding with it. Let's zoom in on that region. And this is my favorite place of atmospheric pressure gradients for the day. And if you're located in those areas, especially like eastern Kansas and eastern Oklahoma, please go out and take photographs of clouds, as you'll see things like lenticular clouds, and we're not going to get into how those form. At least not in this video. By the way, if you enjoy the content, please don't forget to press like and subscribe on YouTube. Hundreds and hundreds and hundreds of older videos to watch there if you're interested in what happened on any date in the past couple of years. Space weather videos all about it. By the way, check out the forums too, smashamash.com/forum. There's a link to it at smashamash.org. Are you familiar with our mission? Well, I guess I'll have to read it. The mission is to assist, study, and report the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects, to connect and consult with media organizations to multiply our reach, to demonstrate cutting-edge proof-of-concept solutions to problems like growing tomatoes indoors over the wintertime, to publish scientific papers in a multidisciplinary manner, including those sciences, but not limited. And by the way, multidisciplinary approaches are more and more important in science. Since everybody has access to all of the information ever known to mankind, it should be a foregone conclusion. Another part of the mission is to assist mankind, the humans, by advancing the study of predictive phenomenon in order to optimize value and do stuff like adapt, no matter what the adversity is. And yes, I mean even things like Carrington events. And lastly, to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to this scientific discussion. Because if you're ossified in your beliefs, folks, you're not doing science. You should be trying to disprove your own theories. And if you're down with that mission, please consider becoming a patron, the real source of financial support for the channel. And again, check out smashamash.org, check out the forum. It's got all kinds of useful information about human health stories and various other things. Shout out to Terry. Here's a clip about how to store your coffee. Now, Terry is a coffee expert. Here's a little clip.
Store your coffee. I have it at a place which is dry. That's the most important, and where it's not too hot.
So anyway, watch that video. Check out smashamash.com/forum. Set yourself a login, create a topic, etc. By the way, stocks are looking like they're going to be lower today. Expecting crypto to be higher, and gold has jumped out once again because of the coronavirus. Now, we've been talking about the coronavirus for at least 3-4 days on the channel. I'll just scroll down this Zero Hedge article so you can read it if you like. And anyway, we saw a coronavirus outbreak happen in Yosemite National Park in the U.S. over the weekend. And then now we're up to over 200 cases and some deaths. It's a very SARS-like virus. We've seen lots of people getting sick in the U.S. There were at least 40 cases of some mysterious illness, which prompted the U.S. to the Park Service to attempt to sterilize Yosemite National Park, all the tourist areas, obviously. So fears over a viral outbreak have got the markets crashing a bit today, as the U.S. Senate wastes its time with a nonsensical hearing, and I waste my time going to a nonsensical hearing to go battle the grass Gestapo again. That's right, the grass Gestapo. They don't like the species of plants that are in the front hedge, and the code enforcement official is suggesting that we do thousands of dollars worth of renovations on the front yard because reasons. So we're going to go battle that as I become the front line in the battle between what the government ought to do and what it ought to never do. Here's a quick rundown of the major indices. I'll just let that scroll for you. I don't know. It's not showing a chart for the S&P. Probably because the market's not open yet. There are the early movers, including Qualcomm. And dollar's down. I mean, the bond is down. Oil's down. Gas is down. Gold is down. Silver's down. The U.S. raised in relation to the yen. No surprise there, as a bunch of holidays kicked off in the Far East. By the way, thanks Smash Team for tuning in. Stay tuned for bonus features, and we've got a few. And by the way, welcome to the Neo Renaissance. For the 90th time, check out smashomash.org, scroll down, click on the link to the newly unveiled forum, and go post a topic. Here's what it looks like. And again, that's the free-for-all portion. We've also got a cosmology section, Earth and geophysics, general science, the sun, free-for-all, and new users. So check it out. Lastly, we're going to look at the local yellow dwarf, and we're going to show you that there are 0 sunspots. You won't see any ombre, but we'll scroll anyway, so you can have a look for yourself. This is a high-res image. And if we miss ombre, hey, leave a comment, let us know. Refute what we've said. When I'm wrong, I admit it readily. I'm the first guy to do it. Let's look at the colorized magnetogram also. And there's the latest of that. And you see that area of magnetic complexity there, north of the equator, which, by the way, is cycle 24 activity. And the plage above it, 2 plages above it, actually. One over here and one over here, both cycle 25 activity. And let's break out a 48-hour movie. And since we've seen a lot of filamentary activity, let's go to the 304 angstroms. Again, this is 48 hours, folks. Move the mouse so we can see the timestamps. There you have it. Thanks for tuning in. Remember, stare at the sun, don't drink, and if you drink, don't drive. Although the government may drive you to want to drink, especially when they take you to court over complete nonsense, and you consider hiring civil rights attorneys and having their entire organization audited, which still could be a thing. Anyway, if you do drink, don't drive. And since it'll never be now again, welcome to the Neo Renaissance, folks. May that solar wind be at your back and that atherosclerosis absent from your veins.